So I don't know if the voice was clear, but that was the last call of a species looking for a mate that will never reply. So what you just heard is the Kawio bird recording in 1987, and that species is now extinct. Its voice is silenced forever, but it only exists through recording like this. That male was looking for a female that never answered. And it's a reminder of what we lose when a species goes extinct. Not just an animal, but a unique sound in the symphony of life. But what if I told you that by listening to nature voices, we can prevent such losses? What if I told you that the key of biodiversity conservation is lying in the voices, sounds, and songs surrounding us every day? My name is Zakher Bouragaoui, and I'm a wildlife ecologist. My journey took me from the southern steppes of Tunisia to the Sierra Nevada in California. And I'm here today to share with you how this the field of biodiversity and bioacoustics is revolutionizing our understanding of ecosystem and giving hope to conservation. So imagine a world when we can detect rare species without even seeing them. Imagine a world where we can understand ecosystem health just by listening to their voices. Or imagine a world where we can detect environmental changes just by decoding audios of nature. My journey with bioacoustics started way before understanding what the word is even. It was in the southern steppes of Tunisia, in the small village called Bir Lahmar. In that village, I would join usually my neighbors in gathering fresh wheat for their sheep. But while the adults are focusing on the real task, I was in another world. I was fascinated by the chirping of insects, the songs of birds. I was fascinated by the leaves and the wind. And I was excited when I see a lizard crossing my path or a bird standing on overarching branch. But that excitement and that love for nature even grow further growing up when my mother woke me up to watch National Geographic documentary each morning through the sound of Sir David Attenborough. And little I knew that these sounds would shape my future. But to be honest, growing up in Tunisia, I never knew that I can do this as a profession. It's only when I went to the university, I knew that fields like ecology and wildlife conservation existed. And it's just a light bubble went up in my head. That's what I wanted. So my journey didn't stop. I took that master and I traveled through Tunisia, from northwest Tunisia, from the oak forest to the desert of Tunisia, from the deep canyon of Midas to the islands of Galit. But my journey didn't stop there. It took me overseas all the way to the Wisconsin, to the Sound Forest Lab. And that's where I started understanding how listening to sounds can revolutionize our understanding to nature. With the Sound Forest Lab and surrounded by the towering tree of the sequoia, I learned how to use machine learning and acoustic indices to understand ecosystem health. Bioacoustics, at its core, is the study of sounds, all the calls in an ecosystem and the ambient sounds in it. But it's not only to record animal noises, but also in its core, it's understanding the communication, nature's own communication. So what I'm going to show now is a visual representation of audio. We call it spectrogram. A spectrogram is the ensemble of all the voices in nature, all together we think of it as a chaotic, beautiful symphony, but when we listen closely, we can each one of these lines is a different species calling. And through bioacoustic, we can break down these soundscapes to individual, and we have a better understanding of this species. But bioacoustics is not only about birds, mammals, elephants, ultra voices of bats. All of this together constitute what we call the biophony. But then we have all the sounds that nature do, sounds of wind, rain, earthquake. All of this, we call it geophony. And then there is our sounds, our disturbance to nature. All the cars, the planes, the login activity, and these are anthrophony. All the three elements together constitute what we call a soundscape. And that's like a landscape, but it's for sound. My work in the Sierra Nevada, California, focused on mainly two things: using BirdNet machine learning to identify bird species and acoustic indices to understand the overall trends in the ecosystem. We deployed over 826 audio recorder, and that to record for 14 hours a day, 4 months, 5 years, in 826 sites. That would give us 220 million minutes of audio. Now imagine the challenge to analyze all that. That would take over 600 years for a single person to listen to all those sounds. And that's where machine learning came to handy, because BirdNet worked as a tireless army of ornithologists who identified over 100 species in all the different sites. And we have insights minute by minute about this species, how they behave, for what reason they call, how they interact with each other. But beyond that, what this data told us, and that's where our discovery lay, is that bird richness, or birds, follow a very unique, beautiful rhythm of activity through the day. They wake up in the morning, and we have two peaks, early in the dusk and dawn, and these are related to the rhythm of their movement, looking for mates, looking for their food. By understanding the rhythm of this species, we can time our conservation efforts and understand when we can make our intervention without disturbing the ecosystem. But also, these findings challenged our understanding of post-fire reaction of ecosystem. While our results showed that bird richness is much less in burned forest and reduced, the overall acoustic sounds get higher. And one wonder why. Maybe other species other than bird like being in burned forest. And this is challenging, especially for people who plan to do post-fire management conservation action. Another interesting finding, we found that in California, birds prefer being in conifer forest rather than broadleaf forest or oak forest. And the other thing was, by analyzing results from different months, May, June, and July, we noticed that birds start their activity earlier in the morning in June specifically. And this make us question why. Maybe this is the effect of climate change on birds' migration to that site. Maybe the abundance of light make birds wake up early, since June has longer days. So all these questions we can answer through using machine learning, but one shouldn't understand the acoustic complexity index, which gave us the overall trends of the ecosystem and shows that focusing on a single species could be also not enough to understand what we need to do in conservation. With all this advancement in technology, with the amazing AI models that we have, the quantum processing computer, and a new state of matter recently dropped, we are heading toward a more global monitoring real-time activity of biodiversity. Imagine having the capacity to understand in the real time what's going on in the Amazon, in the Serengeti, and in coral reef at the same time. While I did my research in California, other people were applying acoustics and bioacoustic in other places of the world, including the Pacific Oceans, where scientists follow whales population through hydrophones. Or maybe they also followed the health of coral reef. Did you know that coral reef is one of the most noisy places on Earth? And this noise, in a recent study, showed that this noise are coming from all the fish species and invertebrate in the coral reef. And even more interestingly, they showed that the coral reef growth is simulated by certain voices of certain fish. Therefore, knowing if those fish exist in the ecosystem can help us understand the health of the coral reef. Another application of bioacoustics was in the Amazonian forest, where we detected logging and illegal logging, but also illegal poaching. And the Sound Forest Lab in the Gabon, jointly with the authorities of the Gabonian government, worked tirelessly to understand the poaching patterns in their forest. And just for reference, over 90% of Gabon is forest. And the authorities can't be everywhere all the time in all this ecosystem. Using triangulation methods and sounds, we detect bullet sounds, and we understand the patterns with which illegal poaching hunt in these areas, looking for bushmeat. And then this result is used to orient authorities where to intervene at what time and what area. But also, bioacoustics was used by local communities to show to their government that their forest is rich enough to be the first national park led by a community in Gabon. But with this, all this advancement of technology and all the information and data that we gather, technology alone is not enough. We need to develop a culture of listening. We need to develop more ethical approach to monitor ecosystem. That's why I invite you to be an active listener. Use your phone. Use BirdNet-like application. Use iNaturalist. By contributing to this global database, you help scientists like me to conserve better biodiversity. But also, it is our duty to be more ethical in using this kind of data and be mindful about what kind of violation when we use this, we commit when we use this data. As a child, I was fascinated by these sounds. As a scientist, I learned how to decode them, but now I'm invited you to conserve them together. In the near future, we'll be witnessing more challenging environmental changes, and our capability to listen to this ecosystem might be our own way to preserve biodiversity. So let's tune in to the frequency of nature. Let's amplify the sound of the wild and make sure together that this soundscape remain resonating for future generation to come. Thank you.
Merci Zakher. Merci.